Virtual donuts.
It's like
That
a
was awesome.
That sounds more like a punishment than anything.
Yeah, no
It was
kidding.
psychology, so it was psychological torture, I think, is what he was really experimenting with. That was a funny class.
It was a
What
fun class.
what's your major, Tara?
Marriage and family studies.
Oh, okay.
Tara, are you taking research, whatever that class is next semester?
Oh, research methods?
Yes.
Oh, I'm taking that class too.
We should all take it together.
We
There you go.
should.
Is it offered online?
Yeah.
Yep.
Really? I didn't know that.
Uh-huh.
That's really good to know.
Yeah. I can do my whole major online.
Really? Wow.
Me too.
And your marriage and family too, Amy?
Yes, I am.
Yeah. And what were you, David?
I'm business psychology.
Oh, business psychology.
Oh.
Mm-hmm.
And your rec management, Dustin?
Yep.
Yeah.
So,
All right. Should we start?
Let
Yeah,
us start.
All right.
Let's get started. Can we go over part 2 of the prep assignment?
Yes. Let's.
I mean, does anybody have any questions on the first one? I thought it was really weird that we did the probability applet. That was really simple.
Yeah, it was simple.
It's like,
so
okay,
number one, what, on part 1 or 2?
part 2. So like the graduate management admission tests problem. Can we go over that?
Yes.
Oh.
Let's.
Okay.
Point estimate for the population mean. So we're really looking for X bar. And it says point estimate.
The pinpoint estimate would be the 541, because it's the pinpoint estimate's also like the number, right?
Yeah.
Yes.
Oh,
Because
okay.
it says the sample mean is 50 and the students is 541.
That would be where you're starting. Yeah.
So
Okay.
then,
The same value that before we'd call X bar, or when you put into your equation, the number you put in where X bar goes.
yeah, X bar is sample mean or points estimated.
Is the point estimate pretty much like always the parent population? Or is it just because of that problem?
The definition I have is it's just one number used to estimate a parameter. And the best one is sample mean X bar.
Okay.
So it's it can be varied, but for what we're doing right now, just think of it as X bar.
As a sample mean. Okay. Sounds good.
And I put the X bar estimates the mean, or yeah.
Okay. Sounds good.
Okay, so that one's 541.
Okay. Then it says create a 95% confidence interval for the population mean. So a 95% confidence. Is that pretty much subtracting 541 from 50 and adding 541 to 50? Or 32, sorry? Like 541 minus 32. Oh, no, because that's a 68. So it'd be 64, right?
So the equation that you're supposed to write out is the 541 plus 1.96, which is the 95%.
That's where we got it from the applet.
And then,
oh.
Yeah, and then you divide that by 32 over the 50.
So if you go in the applet and type in 0.95, that gets you the 1.96. If you just shade in the middle part.
Right.
And they're also kind of giving us a table that says these are the standard confidence intervals, and this is what your z-score is for those.
Yeah.
So I've got a little cheat sheet of those.
Okay, so what does it have to do with the 1 point? Like, what do I do with the 1.96?
So the equation is x bar is plus or minus the z, which is 1.96, times the standard deviation divided by the square root of the n, which is the sample.
Gotcha. Okay. Yep. I see it now. That's what that is. Okay. Thanks.
You're welcome.
So do we have, and our standard deviation is 32, and that's all over the square root of 50?
Yeah.
Okay. And then, so then you have to do it with addition on the other side?
Yeah, you do the exact same equation, but you do one add and then you do one subtract.
Uh-huh. Okay, and that gives you your two numbers for your interval. Okay.
Yeah. So you do like 532.13, and then you put a comma, and then you put 549.87, and you do it in parentheses.
Okay. Right, that makes sense now.
But when I was watching the videos, they said you always round up.
Yeah.
You have like 0.1, you still have to count that 0.1, so it would be 533, and then the other, right? And then the other side would be 550?
Well, if it's 532.1, then wouldn't it just be 532?
I think the rounding up was for when you're looking for a confidence level when you're trying to get a sample size. So, because you can't count, like, you can't count 50.5 grizzly bears or 50.4 grizzly bears.
Right.
So you count 51 grizzly bears. So you make sure you always have enough.
Okay.
Which is an example that works great for Dustin. But
yeah, see, it applies to his major.
yeah.
So, quick question on the N for number 8. Is that 50?
Yes.
Okay. Cool. Thanks.
Yep.
Okay. Say that the sample size changes to n equals 100. Now compute. Okay, so it's the same thing, but now we're just doing 100 instead of 50.
Yes.
Okay.
Then that next part, create a 90% confidence interval for the original 50 students. What's it really asking there?
So we're doing a 90%, so the z would change. So that's pretty much basically it. We change it to the 1.645 or 64. Yeah, 1.65.
Okay.
How'd you get that?
So like in the tutorial videos, it said you can either get that by going through the applet, or they said they kind of listed they had a list where they're like more than likely they're going to be this, and so they listed 90%, and it gives you the standard deviation and the z, and then it gives you 95%, gives you the standard deviation in Z for that, and then 99% it gives you the standard deviation in Z for that in the chart. And so I just plug those, I've been plugging those numbers in, and it's been working. So yeah, so like for
It
instance,
had us do the applet at the first part when you had to go get the Z-score for 0.9, 0.95, and 0.99.
yeah, so like 90%, they gave us a standard deviation of 0.10 with a Z of 1.645, which would round up to 1.65. And then 95%, they gave us 0.05 for the standard deviation, and the Z is 1.96. And then 99% is 0.01, the Z is 2.58. And so if you were to plug, 90% or plug it into the applet, it would give you those same numbers.
Okay. So pretty much number 10 is asking like the relationship. Which is saying that when the margin of error gets smaller, then the sample size gets larger.
Yeah.
Or I guess the other way around, or whatever, vice versa. Does that answer your question, Tara?
I think so. I'm a little behind on this because I didn't get to slug through it on my own, but I think I'm getting it.
It's just more math,
Yeah, just more math.
That's all.
Yeah. They slug into the quiz.
Oh, I mean, it makes sense now. I can kind of see it. It's kind of like the margin of error. Kind of goes like with the standard of deviation. Like as you have more samples to test, then your error gets smaller. Your margin of error gets smaller.
Yeah.
And if you only test like 5 people or 5 things, it's easier to get inaccurate information. I don't know. That's the way I see it. Maybe I'm wrong. Am I wrong?
No, I think that makes sense.
Okay.
So that's talking about how, like, your confidence interval gets narrower. That was a little hard for me to understand, that even though the confidence interval is the same, like it's still 95% or 90%, it gets narrower because the numbers get closer together. That was a little confusing. As your sample size gets bigger.
I see what you mean.
Right.
That's a good question.
Yeah.
You should ask that tomorrow.
Yeah. If I can figure out how to say it. Why is it that, how can it get narrower but the level of confidence doesn't change? And how do you even describe that?
Well, and if you look at like number 11, how it says to create a 90% interval for the original 50 students. So 90%, that's the confidence interval, right?
Mm-hmm.
So it's smaller than 95, but the numbers and the sample size is smaller, but like the numbers when I computed them are pretty close to the ones for number 9 that had the 95% and the 100 samples.
Huh.
So like that doesn't make sense to me. Like, because your numbers are smaller, so how come you're about the same as when you had 95% confidence, level of confidence, and your sample size, anyway. Shouldn't that be more accurate than like 90% and 50 samples?
Oh, that's a good point. Could be.
That would be a great question. For
Yeah. Bring that to the meeting on Wednesday.
Can't go, but maybe I'll email him and tell him.
Yeah. All right.
Okay, so that's pretty much. Okay, that's pretty much what number 12 is talking about. What's the difference between the 95% and the 90%?
Students will meet in a sample. Ensures low poor accuracy of 95%. Playing with these equations just makes my head bug. So you just put that 95% in instead of the 90, right?
Yeah, but you got to do that z-score stuff.
Oh, yeah?
So yeah, the 90 percentile one or 95 percentile one, you do the 541 plus or minus the 1.96 over 32, or 32 divided by 100, and then the other one you'd change that to 1.65 over the 32 to 50. Okay, wait a second. I'm going to cheat and look at the answer document because I'm not sure.
Yeah. It really kind of helps to just work them side by side, doesn't it?
Yeah.
So I don't get where they're getting in the answer document, it says that remember the margin of error is just the second part of the equation. This is for number 12. Or z times standard deviation over n. Therefore, comparing the two margin of errors, the margin of error of the 95% confidence interval level, 95% confidence interval is 8.87, while the margin of error for the 90% is 7.47. I don't get where they're getting those numbers.
Where is that?
It's in the answer document.
For the prep?
For 12, yeah.
That's weird.
I don't know where they're getting that.
That's not what it says in my thing.
There's the worked solutions and the other one. And the answer key. So there's two.
Oh.
There's like two.
Why would they have two different?
I don't know, because the answer key for 12 just says the margin of error gets smaller as the level of confidence grows.
Smaller. Yeah.
So like if you do the problem for number 9, so 32 divided by the square root of 100 is 3.2. And then you times that by the z-score for 95%, which is 1.96. And that gives you the it's like 6.27. So then you minus 541, or 541 minus 6.27, and that gives you it's 534.73. And then the other side, you add the 6.27 to it. So those would be your two, like your high and your low.
I'm just wondering where they get the 8.87 and the 7.47. Anyways.
Oh, that must be referring to, okay, so number 8, you have the 95% confidence interval. And when you work that out, that gives you the 8.87. And then on 11, is that 11? Yeah, the 90% confidence interval, that gives you the 7.74. So that just must be referring back to 8 and 11.
Oh, where are those two numbers coming from?
Okay, so if you go to 8, number 8, how it says, hold on, let me find it. So it says create a 95% confidence interval for the population mean. So that's when we did the 541 minus 1.96 times 32 divided by the square root of 50. Right. That thing. So when you work that out, when you do, like if you just work the 1.96 times 32 divided by the square root of 50, that gives you the 8.87.
Okay.
And that was like the z-score?
The z-score, the z is the critical whatever that's called.
Oh, yeah.
So that's the 1.96.
I see.
So that's where that 8.87 is coming from.
I guess I'm just not seeing it because I'm using a calculator to just do it all in one fatal swoop.
No.
You're just pretty much taking out the, what's it called? What's that part? Where'd it go? Hold on.
Are you just doing the...
Yeah, you're just taking out the 541 plus or minus.
Okay, so you just do the square root over the 50.
And then times the 1.96. Which is the same. That's the same thing for the margin of error. That's the same formula. Is the z-score times standard deviation over n, or square root of n.
Okay, I see how you got it.
That's the same formula for margin of error. Ugh.
Yay, okay.
Clear as mud?
Clear as mud to me. Yeah. I say let's just slug it out through this quiz because...
Yeah.
Yeah. What?
It's just messy. It's just going to be a battle for me today.
Alrighty.
Alright, so we need to find the margin of error of a 90% confidence interval when the standard deviation is 50 and the number is 25. So round to the nearest decimal. So this is are we going to use that z times the standard deviation over n for this one?
That looks right.
So 90% would be
1.645.
Yeah, so 1.65.
And the margin of error. Yeah.
Yep. Square root of 25. Okay.
Over
50.
Okay. So what everybody get?
I got 16.45.
Okay, I thought my answer was going to be very different, but it's not. That's good.
That's the same? Same?
Yeah. 16.5.
Right.
Yeah. So mine though automatically rounds up, so it's just 16.5.
Oh.
Does it round to the nearest 3 decimal places?
Wait.
So
do we need to put a
16.5?
16.45 is what I got.
Oh.
So if we have to do it to 3 decimal places, do we have to put a 0 on the end just to say we're all the way there?
So I think you'd need to round the 4 up to a 5. So it'd be 16.500 maybe.
Oh.
Huh.
Yeah.
I think I'd leave it the 4-5. I think I'll leave mine the 450.
Wait, you got 16.45?
Yeah.
How'd that happen?
Well, because it's point.
Huh.
So I did parentheses.
1.45 times 10.
I got 16.5.
Yeah, so like I did parentheses 1.65 times 50 divided by the square root of 25, and then I closed the closed the parentheses, and it gave me 16.5.
Or, yeah, you can even just do 1.65 times
Oh,
10.
this is one of the things that if you do 1.64, was it 645? That makes a difference. Because
yeah,
5 times 10 by 1.645, then I got 16.45.
Yeah, I see it. You
So
just
you
didn't
gotta
round the, you didn't round the z-score.
Yeah, yours is rounding too early, I think.
So like if you round the z-score up to 1.65, then you get 16.5.
So are we not supposed to round that up, or are we supposed to round it up?
I don't know.
I think you shouldn't, because you shouldn't round till the very end. So.
I'll volunteer as tribute when we submit. And then if it's wrong, because I know for the prep assignment it asks us to round.
In the beginning?
So, yeah, it asks us to round to the nearest hundredth.
I hate the rounding concept. Stupid. Oh. Not going to complain about my kids' math homework ever again.
Okay, so the next question says, which of the following statements is true? Which one's the point estimator?
X bar was a point estimator. I remember that.
X bar is?
Yeah. X bar is a point estimator.
Yeah, of the sample mean.
Yeah.
And that's what mu is the sample mean. So.
Okay, so it's the third option?
Yeah.
Okay.
Yeah.
Sounds good.
Very.
Gina wants to construct a 95% interval for GMAT scores. She knows the standard deviation is 113. She collects a simple random sample size of 64 and computes the sample mean 526. So what is the lower limit of this confidence interval? Ugh.
We've got to do that big long one.
Stuff.
So we do.
So that's where we do 526 minus 526 minus, and then 0.95. What's the z-score for 0.95?
It's 1.96.
Yeah, 1.96.
Okay. Yeah, so then 526 minus 1.96, and then parentheses.
That's times? Is that times?
Yeah. Yeah, times 113 over
64.
Yep.
The square root
Square root of 64.
Okay.
So, yeah, 526 minus 6.
So that's 14.125 for that in the parentheses,
Uh-huh.
right?
Yep.
Okay.
And then times that by 1.96.
For 27.685.
Yep. And then 526 minus that.
Okay.
I got 498.315.
I got that too.
Okay.
498.315. Yep.
Okay.
And so, if we were to round that to the nearest 3, would that be 32.0?
I did 0.315.
Yeah, I think it's the fourth number. The fourth decimal would have rounded to the third one. I'm pretty sure. I'll volunteer as tribute as well.
Are these ones where you do have to have whole numbers too?
No, because it says round to the 3 decimal places.
Yeah, it says round to 3.
Okay.
Yeah. So
then we get to do the same thing but addition.
Yep. Same thing with adding.
So it's 526 plus 27.685?
Yes.
Okay.
Oh, yeah. Got 553.685.
That's what I got.
.685.
Oh, dang. Yep. I got the same.
Okay. Great. It's nice when the quizzes make more sense than the homework.
Yes, isn't it?
Uh-huh. So far, so good.
Knock on wood.
Yeah.
Okay, so number 7. What would happen to the width of the confidence interval if Gina increased the sample size?
It would narrow. So decrease, right?
Sounds good to me.
Sample size.
Yeah,
but what if she increased her confidence interval? Then sample size.
As the level of confidence increases, the width of the confidence level increases. So 8 would be increase, right?
It's increase.
Yeah, that's what I got.
Yep.
All right.
Well, changed it. Do we know anything? Okay, this is Gina's. Okay. It is still referring to the above 95% confidence level. So it is growing. I was just making sure that we knew it was growing. So it increases, right? Is that what we said?
Yeah.
Yeah.
Okay. Brightful Light Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is sigma equals 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? Okay.
So this is the formula is n equals, and then here I'll just show you.
N equals Z times sigma over M.
Yep. Over M. Yep. And then square all of it. Yep.
And then you square all of it?
Yeah. Here, I'll write it down.
Oh, there it is.
You
I found it. Yeah.
Okay.
So 36.
So it's 1.96, right?
1.96.
Yeah.
Times 400 over, what's M again? Margin of error?
Margin of error.
50. So it's
hours.
over 50.
Okay.
And then all of that, it gets squared.
Oh, wow. We have like all the numbers we need and everything, right?
Yep.
That's super.
Enjoy it while it lasts.
Right.
All right.
Okay. Did you get 245.8624?
Yes, that's what I got.
Okay.
I don't know how to do squaring on my little calculator, but it's just times 15.68, right?
Uh-huh. And then this one says to round to the whole number.
And that was 245.8624.
Yep. So then the answer would be 246.
246. Right.
On this one, we need to round to the whole number, so yeah, it'd be 246.
Oops.
46. Is this the...
Yay, we're down to the last 3 questions.
Hooray!
We'll probably get this done in our allotted time.
Well, kind of, since we started early.
We got our chit-chat out of the way first, right?
Yeah. It says the mean salary of actuaries is 100,000. Standard deviation is 36,730. Interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it's higher or lower. You set up a hypothesis test of level of significance of 0.05, and then the alternative and null hypothesis. You collect a simple random sample of n equals 36 women's salaries and find that X bar is 111,000. So what is the lower limit of the 95% confidence interval? The lower limit.
So this is like merging last week's lesson with this week's lesson, right?
Kind of. So
go back to that lower limit.
So back to that formula.
X bar, 111,000.
Okay, yeah.
Minus. And Z is
1.96.
Yes.
It's what?
1.96.
Oh, because it's the 95% confidence level. Okay, thanks.
Mm-hmm. And then times, what goes up top again?
Sigma is
sigma
36,730.
Yep. And
over square root of 36, right?
Yep. It's pretty much just giving us a bunch of useless information from last unit.
Yes, it is.
Trying to be tricky.
So I got 99,002 when I rounded up.
I got 99,005 when I round up.
So I got 99,001.53333333.
Yep,
Okay,
that's
so-
what I got.
And then I rounded it up to 99,002.
Yep, that's what I got.
I have a dumber calculator than you guys, so it always takes me longer to.
Yeah.
66666.
And that was subtracting, right?
Yeah.
99,001. Is that right? I got 99,001.53333. Is that right?
Yep.
Okay.
So then 1, 2.
Okay, so what did you guys get?
So what I did is I did the parentheses in the calculator, then I did 111,000 or minus 1.96. So minus 1.96 times 36730 divided by the square root of 36, and then I did a double close parentheses, and that's what I got is the 99,001.5 whatever.
And for the upper limit, did you guys get 12,000? Wait, 122,998.46666?
Yep.
Yeah.
Okay.
And so that wouldn't round up at all. So it'd
Yep.
just be
That's correct. Or, I agree.
122,998.
Oh, there I got the
agree.
99,002.
Okay.
You got that for 11?
No, I'm
No,
still
for
working
10.
on 10.
Oh, okay.
Okay, this is much more straightforward than the homework was. This is nice.
Yeah. I just hope there's no question saying explain the 95% confidence interval, because I don't know.
Yeah.
Okay.
I just know
11,
plug
you
in
guys
numbers
got
into a
what did you
formula.
Plug it in, yeah. Three requirements need to be checked when computing a confidence level for a mean. They are. Well, if there's 3, then I guess I'm going with all of the above, right? I love that question.
Okay,
Wait,
so
I think
let me go back to 11. Did you guys get 122,998?
Yeah.
that's correct.
Okay, good.
Woohoo!
I figured it out.
Oh, wait. This is very similar. I think. Oh, here it is. So the 3 things that need to be checked are a simple random sample was drawn from the population. So yeah, and yeah. You're right. All the above.
Not a trick one, huh?
Nope. All right. I'll volunteer as tribute.
Okay, tribute.
Okay, here we go. Oh, so number 3 was wrong. 16.500 is incorrect. What did you guys say?
I had 16.450, so I'll submit mine and we'll see if it's.
Okay. Did it work?
It worked.
Oh.
Yep.
Darn it.
16.450 for 3.
Okay. And everything else was right.
Yep.
Yay!
Okay.
Hooray!
So now for 5 and 6, you got 498.320, right?
For what?
For number 5.
Yeah, 498.315.
So for number 5 is 498.
315.
315.
Okay, and then what was number 6 then? 553.
685.
Because I had rounded those ones up too, so I was like, okay, I should change those then.
Yeah.
See, the rounding, it just kills you.
It does.
It's true.
All right.
All right.
Awesome.
Group.